Hello friends, welcome back for another video. You asked me for more interview assignments and exercises, so we will take a quick break from Azure and this time solve an interview exercise I was given in the past for a data engineer position at a big UK construction company. It's language agnostic, so you can use whatever language you want. I used Python, and it's about collecting data from a public API regarding crime in the UK and find a way to present those data. I want to mention it's a very cool that the police in the UK make this data public. It's quite interesting data that you can play around with and actually implement a lot of stuff if you have enough imagination. Bear in mind there are multiple ways to solve this problem, which could be even more efficient than the one I'm going to show you. Having said that, let's see the description of the task and analyze the API data. But before we do that, subscribe to the channel if you are new. Let me minimize my camera and start reading the description of the task. Here we are. Using the Police UK API, extract the data related to street-level crime and outcome data as well as the nearest police stations. Create a single database that will contain all the street-level crime and outcome data with the nearest police station that have investigated the crimes and remove all the data that have a missing outcome, while highlighting which authorities do not provide an outcome. Present a sample of your data with a code and a brief document explaining your thought process for the technologies you have selected. I'm guessing here they mean single dataset, not a single database. There is no reason to actually save the data in the database unless we are actually performing an ETL task in a later stage, but we are not doing that here, so I assume they mean dataset. This is the website that has all the police data. I'm going to provide the link in the description, don't worry about that. So you can see under the data tab, you can download the dataset using all these drop-down menus and click here and select which crime data you want from which police station, and it generates a file and you can download it and play around. However, after all, we are data engineers, so we are going to use the API. Now, this API provides a lot of data in many different ways. For example, here under force related, it provides a list with all the police forces in the UK, the ID and the name. In the response description, you can find the description. Here, the ID is a unique force identifier and name is force name. If we go back again, you can also check the specific force based on a location. And here it provides a description and all those stuff here, all those descriptions about this police department. And of course, you can also search for the officers for each police station, which is kind of cool if you ask me, because you can search, you can tell if a police officer belongs to this police station and has his CV, actually bio, the name and the rank, etc., etc. It's quite cool. Now, our street level crimes API endpoint. This endpoint provides crimes at street level, either within 1 mile radius of a single point or within a custom area. The street level crimes returned in the API are only an approximation of where the actual crimes occurred. They are not the exact locations. We don't really care about those because we are not detectives, we are data engineers. But here is the part that we want, the request parameters. If you want to get the data for a specific point, a very specific location, you provide the latitude of the requested crime area and the longitude of the requested crime area. Date is optional, and this is the format, year and month only, that limits the results to a specific month. If you want to use a custom area, you use the poly variable request parameter, and you define the custom area. This is an example of how you define the custom area. If a custom area contains more than 100,000 crimes, the API will return a 503 status code. Okay, and the API will return a 400 status code in response to a GET request longer than 4094 characters. Examples of those requests could be something like this. This is the endpoint, crimes-street/all crime, and question mark, and then latitude, lat for latitude, and longitude, LNG for longitude, and the date, right? And the custom area for the poly argument, poly request parameter here, you provide this custom area and the date. And this is an example response. Now we have the category of the crime. So here, antisocial behavior, the location type, force. So the police investigated this crime, the location, the latitude, street, longitude, the name of the street, persistent ID, location, month, etc., etc. Here you can see what all those variables mean here, all those parameters. Street, the approximate street of the crime, ID, unique identifier for the street, name of the location, etc., etc. Now, here in the category of the outcome, we have the code and the name, which its name corresponds to the respective code here. Okay, so let's go back to another endpoint and see the street level outcomes. Here it's exactly the same, outcomes at street level, either at a specific location within 1 mile radius of a single point or within a custom area. Again, you can provide the date, the location ID, or the coordinates, or the custom area. And it's going to return, this is like a sample, a response sample of this endpoint. The category, the code of the crime, and the description of the crime under the name variable, the person ID, the crime, and the street ID, name, longitude, etc., etc. Persistent ID. Actually, I think persistent ID is the unique identifier for that crime. Now, it's good that you have IDs so you can connect the dataset between endpoints. Another one is crime at a location. So at the specific, you provide the specific location, and it returns all the crimes for that location. The same, the crimes with no location, so returns a list of crimes that could not be mapped to a location. Crime categories, and as you can see, we have all, like this dataset here, it returns a URL with the code of the crime and the description, unique identifier, and the name of the crime category. Now, this dataset here could be used perfectly for a lookup table to join the code, the unique identifier, with the code from the outcome and get the description. Another thing here, we have the last updated. The crime data in the API is updated once a month. Find out what it was last updated. Now, if we check, actually here, if we hit that endpoint here, it will return December of 2022. So we have last year's data. And here we have the outcome for a specific crime. Again, returns an outcome, case history for that specified crime based on the crime ID that you provided. We have the neighborhood related that actually returns list of neighborhoods for a force. So this force has all these neighborhoods under its provision. I don't know how it's called. And we have also the locate neighborhood at the bottom, And here we can provide a particular area like the latitude and the longitude and get which police department is responsible for this area. Now, why this is important? Because actually the way I did it is to use these endpoints, street level primes, provide a custom area like Suffolk, for example, with this exactly with these coordinates here, and it's going to return a result like this. So we have the category of the crime, and the outcome status. Sometimes it's null, sometimes it's not. And also we have the latitude and the longitude. And I'm telling you why I'm using this endpoint and not the street level outcomes, because here we can also provide the latitude and the longitude, and we are going to get a very similar response. We also have the code and the name here, which has the description. Based on the description of the task, as you can see here, we need to remove all the data that have a missing outcome. And using the street outcome endpoint, well, I tried it several times, and when it returned all the results had outcome status, and I'm guessing while the street level endpoint sometimes provided null values. So I'm guessing this is what you want to use, the street level endpoint, otherwise it wouldn't say here to filter for a missing outcome. So back to the website. Here, that's why I used the street level primes, and I got the status, the outcome status. Here, sometimes it's null, sometimes it's not, the latitude and the longitude, because I used this custom area here, which is a large part of the UK, so it contains many different locations. So it provides you with like the response has many different locations, and I got the latitude and the longitude from here, from this response, and the outcome status, and then underneath the neighborhood related endpoints, I used the locate neighborhood endpoint. I passed as a parameter the latitude and the longitude, and it comes back with the police station that is responsible for this location. Now that we have an idea about the data and what kind of data we are expecting, let's move to the code. This is the way I did it. I used NumPy, Pandas, collections, AIO, HTTP for asynchronous requests to improve the performance, asyncio, and date utils, and matplotlib for a chart. Let's move into our main function here. So if it's main, then just run main and use asyncio. So we can use asyncio to improve the performance and achieve concurrency. Although in this example, we are not going to achieve concurrency, we are just to use the coroutines in order to improve the data. And the reason I didn't use asyncio I didn't create tasks and use asyncio and run all the tasks concurrently is because actually the API does not allow to retrieve data so fast. There is a limitation of how many times you can hit this API. So I just used coroutines to improve the performance of the code, because we are going to hit the API multiple times, but not overdo it. So under the main function, I have defined the getData function here, which is actually an asynchronous function that uses the AIO HTTP module, and we create a client session and we hit the API asynchronously, and we are waiting for the response. So because we hit the API, different APIs and multiple times, I thought it's better to have a function, and so we don't have to repeat our code multiple times. So the first thing we need to do here is to get the results from the first API, which is the crime API that contains all the crimes here. And I passed as parameters the date, which is this date here, which is the daytime now, so it's the current date minus 2 months. That's why I used the dateutil package here. We extract 2 months from the current daytime and we get December 2022, and this is the past date. We format the date as we want, year and month, and here in the parameters we use date, December 2022, and poly. So I took this location from the website, and I'm using, I think it's Suffolk and another area, I don't remember exactly, we will see in the results. And then, so we hit this crime API with those parameters. We wait for the results and get all the crime data. And then I create another function to populate a dictionary with the results we want. So here is the function. We populate the dictionary. I use the default dictionary because I want a dictionary with lists. We are going to assign the data we want into separate lists inside the dictionary. That's why I use the default dict. And then I iterate through the results, and for each result I get the latitude and the longitude, and then I pass those parameters to the second endpoint, which is the locate neighborhood, which we are going to get which police station is responsible for that location. Remember, we need three results: the outcome status, the outcome of the crime, the crime itself, the category of the crime, and the force, the police station that was responsible for that area. We are getting the outcome and the crime from the first API response. We have the latitude here, the longitude, and we can also get the outcome status, the category, and the category of the crime. So here we add an if statement saying if the result is not none, so if there is something, and if the category, there is a key in this JSON data, then just get the outcome status and category. So we jump into, we go down 2 levels. First the outcome status, then the category, right? Else append none, and then we have the crime. We can implement the same check if the crime exists as a key in this JSON, but we can also skip that for now because I found out there is no none result in this column, in this field, although I have added this try and except statement. So if there is no key, then raise a key error, so a key is missing from that JSON, and we cannot get the crime, let's say, data or the force data. So the force data is coming, so which police station is responsible for that location, it's coming from the second API. So we hit the second API passing a different URL, which is this one, the locate neighborhood URL, and we form the parameters here, which is Q is the parameter and the request parameter. This is based on the API documentation, and then we provide the latitude and the longitude according to the documentation, and that gives us the police station that was near this area and was responsible for this area. So we have all this data and we return this dictionary. Then the next step is to actually create a pandas data frame from this dictionary, and we get a data frame with 3 columns: the outcome column, the crime column, the force column, and all the data that we collected from this iteration. So now we have a pandas data frame. What do we do? I personally think it was a good idea. That was a very, if you have this ETL mindset on your mind, I created a flag because the description says that we need to know which police stations did not provide an outcome. So what I do in the data frame, I create a new column called flag, and I check if the outcome is null, so that just assign 1, else 0. And I'm doing that so I can tell which police station didn't produce an outcome. Then we display the results. I create another function, a separate function, to display the results. Now this is something very subjective because it doesn't specify how to present the data, and that's why I used this way, although maybe it's they wanted something else. So what I did was to actually select all the forces, the force column from the data frame, where the flag, so the flag column equals 1, and then we provide a distinct use.unique, and it will return a list of all the police stations that didn't provide an outcome. I'm guessing there are multiple ways to do that. That's a very ETL way to do. That's what you would usually do in the database, create a separate flag column and just assign 1 or 0 according to your criteria. Then we drop all the null values according to the requirements. It says drop all the null values where the outcome doesn't exist. So we drop all those records and we are left with a data set that all have outcome. Then I perform a group by based on crime and the count, and I create a new column called count, and I provide a bar chart with x-axis being the crime and y-axis being the count, and I display the graph. Let me run this and I will show you the graph. Okay, so this is the list of police stations that didn't produce an outcome of the crime. And let me switch to the plot here. This is the bar chart. As you can see, we have the count for each category, crime category. So for example, February, that would be about 8 crimes for this particular area in the UK. This highest bar here is for violent crimes, unfortunately. So there are many violent crimes in that particular area. Now, as you can see, this dataset is a very, very cool dataset, and you can actually play around and create more comprehensive dashboards and visualizations and all those things. So you can also use data science techniques in order to help our fellow policemen and prevent crime. Could we actually improve the answer? Yes, we could get a data frame with all the outcome codes and descriptions and use it as a lookup table using left outer join with our main data frame in order to get the descriptions of the outcome status. Nonetheless, this is very easy. You hit the API, you save the data into a data frame like we did here, and you join the data frames based on the outcome code. But I will leave this one to you. This is everything for today, guys. I hope you enjoyed the video. If you like the video, click the like button and subscribe to the channel, and I will see you in the next one.